and can cause severe burns to the skin and eyes without proper protection. It is best to wear rubber gloves, a rubber apron, and goggles or a face shield while servicing the battery. If you should spill electrolyte on your skin or clothes, wash it off immediately with plenty of clean water. If electrolyte is splashed into your eyes, wash them with clean, fresh water and get medical help immediately. There are two methods of charging nickel-cadmium batteries, the constant voltage and the constant current methods. The constant voltage or constant potential charger applies a fixed voltage to the battery. Because of the low internal resistance of the battery, the initial charging current will be high. If charging current is too high, damage may occur to the gas barrier in the plate separator, which in turn could lead to thermal runaway, discussed earlier. With proper control and monitoring, the charging current will reduce automatically as the battery reaches a full state of charge. The charging systems of most aircraft are the constant voltage type. Voltage must be carefully regulated to prevent excessive current flow and thermal runaway. The preferred method of charging a Ni-Cad battery is the constant current method. Charging current is regulated to remain at a constant value throughout the charging cycle. Since the specific gravity of the electrolyte in a Ni-Cad battery does not change with the state of charge, a hydrometer will not indicate whether the battery is charged or discharged. The only way to accurately determine the condition of a Ni-Cad battery is to first charge the battery fully and adjust the electrolyte level. Then the battery must be discharged until the cell voltage in each cell is about 1 volt. The battery is considered to be fully discharged at this point. Note the time it took to discharge the battery and calculate the ampere-hour capacity of the battery. If the ampere-hour capacity is less than rated capacity, the battery must be reconditioned or deep cycled. The battery is discharged at a slightly lower rate than for the capacity check. When the cell voltage reaches about 0.2 of a volt, or 200 millivolts per cell, metal shorting straps are placed across the terminals of each cell and left for about 3 to 8 hours. This assures that all of the cells are equally and completely discharged. The battery is then placed on the charger and is charged at the 5-hour rate for 7 hours. The total charge on the battery will be 140% of its 5-hour rated capacity. At the end of the charging cycle, each cell should have a voltage reading between 1.55 and 1.8 volts at a temperature between 70 and 80 degrees Fahrenheit. Any cell that does not meet these criteria must be replaced. Before reinstalling the battery in the aircraft, check for electrical leakage between the cells and the battery case by placing a milliammeter between the positive terminal and the case. If there is more than 100 milliamps of current flow, the battery must be disassembled and thoroughly cleaned. After the battery has been reassembled, check to be sure that all of the terminal connectors are tight. Here are a few reminders about servicing Ni-Cad batteries. Remember that the electrolyte in Ni-Cad and lead-acid batteries are chemically opposite. Never store or service the two in the same area. Separate servicing facilities should be provided. Never use tools that have been used for servicing lead-acid batteries on Ni-Cad batteries. Check the service logs of the batteries you maintain for hints about any developing problems. Be sure that you make the appropriate entries in the log so that a continuous history of battery maintenance and performance may be kept. When handling battery electrolyte, always wear protective clothing. Should any be spilled on your clothes or skin, wash with water. Wash thoroughly and get immediate medical attention if electrolyte gets into your eyes. Be sure that the battery and the battery compartment are clean and dry, and that all terminal connections are properly tightened before putting the aircraft back into service. Be sure that the battery compartment has been thoroughly cleaned and inspected for damage or corrosion. Make any necessary repairs and repaint the area with an alkali-resistant paint. Check the battery venting system. Be sure that the pad in the sump jar has an adequate supply of boric acid solution. Be sure that the vent lines are open and in good condition. Check the area around the overboard vent for evidence of damage or corrosion. Clean the area and make any necessary repairs before repainting. This program has explained in general terms the testing and servicing procedures for nickel-cadmium aircraft batteries. It is meant to serve as a guideline and should aid the student in understanding the theory and servicing techniques necessary. For detailed information on the